Welcome to solverfy.
Hello everyone, today we're doing chapter 19, problem 32, and this problem asks us to rank the following compounds in each of these groups A and B in order of increasing boiling point. So what do we know about boiling point? Well, the more polar your molecule is, the higher the boiling point is going to be. And so how we can determine that is the number of polar atoms or electronegative atoms on a molecule. You can determine that by the number of hydrogen bondings that can form on the molecule. So let's look at A. So if we look at the most left example, we can have a hydrogen bond donor and a hydrogen bond acceptor from these two moieties on this carboxylic acid, one being hydrogen bond donor from the carboxylic oxygen, one being the acceptor from the carbonyl oxygen. In the second one, we only have one hydrogen bond donor, and in the third one, we also have one hydrogen bond donor. So right off the bat, we can say that this one, having more interactions with other molecules of its own or with water, this is going to have the most highest boiling points because it is the most polar. So this is going to be the highest boiling point. Now, what about these two? Well, here we have an ether, here we have an alcohol. So this alcohol can be deprotonated to get a full negatively charged oxygen. So a full negatively charged oxygen is quite more polar than just an oxygen in between these two hydrocarbon chains. And in fact, there is an internal plane of symmetry in this molecule. So this is actually a non-polar molecule. This is if we lost a carbon on each side, this would be diethyl ether, which is actually an organic solvent. And this would most likely have a boiling point which is well below 40 degrees or room temperature. So, I mean, if you were to open a bottle of this overnight, it would be gone the next morning. So, because we can have a full negative charge on this alcohol, this is going to be more polar than this ether molecule. So this is going to have the intermediate boiling point, and this is going to have the lowest boiling point. Now, using that same logic for the group B, we can see that this carboxylic acid has obviously two hydrogen bonding, while each of these can only do one. So right off the bat, we can say that this is going to have the highest boiling point. And now what about these two? Well, once again, this alcohol can be fully deprotonated to make a full negative charge on this oxygen molecule, making it a lot more polar than this ketone, which can't really do anything other than just accept hydrogen bonds. So because not only this molecule on the right can participate in hydrogen bonding, but it can also participate in electrostatic interaction, this has more intermolecular forces, thus increasing its boiling point with respect to this ketone, showing that this is going to have an intermediate boiling point, and this ketone is going to have the lowest boiling point because all it can do is just hydrogen bond.